Hi, my name is Eitan Suez, Technical Marketing Manager at solo.io. And in this presentation, I'd like to discuss how Ambient Mesh challenges the security gaps in sidecar workloads. Service meshes brought much improved security posture to microservice architectures. We'll go over that initially. And the Istio project, being one of the main, most widely adopted service meshes out there, today offers a mode known as Ambient mode, which represents an evolution of the service mesh platform with focus on efficiency and isolation. What I want to do is explore how this Ambient mesh further improves on the security posture beyond what sidecar-based mesh has accomplished in the past. And so let's begin with a review and think about how the security posture in general in service in microservice architectures has changed over time. We started out by, or enterprises started out by breaking up monolithic application into microservices, and initially the security model was relatively shallow. It was based on the concept of perimeter security, where there was a great deal of security at the edges, so to speak, ensuring that only clients that had access to a system were able to communicate with it. But internally, microservices communicated with each other without any encryption, without the notion of workload identity, which was brought on later on by service meshes, and services implicitly trusted one another. There were attempts along the way to try to improve on this security posture by perhaps giving teams additional responsibilities to mint certificates for their applications and rotate them, but that became an added burden on an already full plate, so to speak, and that approach didn't really go too far. So just to try to illustrate the scenario, imagine just this is a simplified illustration of an environment with multiple microservices that communicate with each other via API endpoints or what have you, and there is a sort of maybe an ingress gateway depicted here that allows traffic into the environment, but the security is at the perimeter, and these services are allowed to call one another freely. And this implies that if a service, whether it's one that's allowed to operate in this environment, is calling a service that it shouldn't, or whether it's some kind of penetration where you have some kind of rogue element trying to make calls that's inside this environment, they have access to everything. They can call all of these API endpoints freely. And so that was sort of the original picture that then service meshes improved upon. And here you see on the right hand side one of the canonical illustrations from the Istio project that illustrates more or less how Istio sort of rigorously and systematically solved this problem by securing network communications through the concept of X509 certificates assigned to workloads that essentially represents a network identity, a workload identity on the network, whereby here you see the control plane plays a role in delegating to a certificate authority the verification and the signing of a certificate, which is then issued to a proxy that resides inside the pod where the workload actually runs. And that's essentially how the sidecar mesh is able to perform a mutual TLS communication with authentication of workloads inside a mesh. Now this dramatically altered the picture. It allowed us to essentially move to the concept of zero trust architectures or environments where traffic between microservices is not only encrypted and authenticated, but the notion of trust but verify sort of is present. So now we have essentially sidecars. They're represented by these pink hexagons inside each workload that essentially take over the responsibility of encrypting and establishing this mutual TLS handshake between microservices. So the entire end-to-end communication is secure and the identity of every workload is known. So in this picture, imagine some kind of pod that's not allowed to operate in this environment somehow managed to get in, they're unable to call any of these services because they do not have that certificate necessary to perform to identify itself vis-a-vis other services it calls. And maybe there might be a way, maybe by taking over one of the running applications and trying to assume its identity or something of that nature. But this is a much stronger security posture. And so that's sidecar-based mesh in a nutshell. So let's talk about ambient mesh. And the first statement I wish to make is that it continues to provide the same sort of guarantees. The idea of workload identity is carried through mutual TLS, encryption of traffic between microservices, authentication, but it does so without sidecars. So you might have seen maybe a picture promoting ambient mesh looking something like this. And when I see this illustration, one thing becomes clear is the sheer number of workloads in large enterprise environments creates a very big difference in terms of whether or not you're going to have sidecars. So in a sidecarless environment, you're using much less compute resource when you're running ambient mesh. So the question becomes, well, how can we actually have sort of our cake and eat it too, so to speak? Establish a secure zero trust environment with mutual TLS without these sidecars. Now, there are still proxies. They're not depicted in this picture because it's a little bit difficult when you think about it. When we begin to describe how ambient functions, we are starting to use shared proxies that one per node. We have some new components. There's obviously we still have the Istio control plane. There is still a mechanism primarily through a CNI plugin, the Istio CNI node agent, to sort of ensure that traffic can be sort of intercepted on its way in or out to each workload, so that we can then perform this augmentation of or enhancement of communication or traffic between microservices. But now we have a couple of new components, the ztunnel being a layer 4 proxy, which is a per node proxy, which is going to not be dedicated to any single workload, but rather be a delegate that represents and does work on behalf of all the workloads running on that particular node inside the cluster. And then there's the waypoint, which is essentially, again, still our Envoy proxy, but in a very different form. It's not co-located as a sidecar inside the pod. It's a standalone proxy, sometimes called a micro proxy, a waypoint, which has full layer 7 capability. So when we actually try to take a closer look at how the communication happens between clients and services, we see here a couple of clients, C1 and C2, and one called C3 on another node trying to call service S1. We see how that communication is routed through through a pair of proxies or a single proxy, depending on whether the ends of that communication are on the same node or not. And we also see something called HBONE, HTTP-based overlay network environment, a mechanism for tunneling and efficiently multiplexing connections and requests between multiple parties. And so we have mutual TLS and encryption, but without the sidecars. And it's really interesting how that works. There's a lot of documentation on the Istio website and on ambientmesh.io that explains how that works in more detail. But let's carry on. So just briefly how things work. We see here a depiction, an illustration where the ztunnel is configured just like a sidecar used to be in sidecar mode by the Istio control plane with discovery information and with the certificates. And in this case, it's certificates in plural because it's the certificates of any workload that this ztunnel component is going to proxy. And so there is this mechanism of instrumenting the ztunnel. Where we need layer 7 policy enforcement, we deploy a waypoint, and we can do that in Ambient Mesh on demand, and that's primarily piggybacking on the fact that Ambient Mesh depends on the Kubernetes Gateway API, which provides this sort of capability, native capability. A waypoint is deployed as a gateway resource, which then automatically causes the platform to provision the necessary gateway. And here what we see is a request we have a service S1 which is fronted by a waypoint, and so the ztunnels know to direct traffic to the waypoint that represents the service, so that that waypoint can implement layer 7 policies, whether they're authorization policies or traffic routing policies or something else. But what we see here is a nice separation. Whereas in sidecar mode, we used to have a co-location of sidecars, of Envoy proxies, inside a pod. We're no longer doing this sort of surgery. It's no longer an invasive mesh. It's a mesh whose components are now clearly separated, have their own delineation from your workloads, and that has a number of benefits which we'll discuss momentarily. And there we are. So, benefits. Let's go ahead and itemize some of the benefits that derive from no longer needing to inject a sidecar in every pod. And first and foremost in my mind is the notion of simplicity. And it reminds me of something that's very popular today, that's been made popular, the notion that in design the best part often is no part, which asserts that maybe the most effective and reliable systems are those with the fewest components and the least complexity. And so we no longer have a sidecar at all. Efficiency. Not running an Envoy sidecar inside every single pod, especially in large environments, has huge ramifications in terms of resource use, compute and memory resources that are required to run a fleet of Envoys inside your cluster. That's no longer necessary. We deploy waypoints where we want them, where we need them, and the ratio of Envoy instances in the old versus new mesh can be sometimes staggering. And then from there we derive a lot of cost savings, right? The higher efficiency translates directly into compute and memory cost savings. So we don't require as much memory, as much compute in order to run our mesh. And then there are operational gains derived from the fact that we no longer tangle or commingle or couple application workloads with their Envoy proxies. They're separate deployments, and that means that we can upgrade our mesh without disturbing our applications. We can patch CVEs and waypoints if necessary without disturbing our applications, and vice versa. We can redeploy our applications without being concerned with the fact that there is some kind of sidecar running in there that needs to come up first or what have you. So a lot of benefits to running ambient mesh. But let's talk specifically about the security benefits, which is, after all, the subject of this presentation. How does Ambient improve on the security posture of a system of microservices over a sidecar-based mesh? So the first point I'd like to discuss is the notion of a reduced attack surface. If you just think of the ensemble or the aggregation of all of these Envoy proxies, the Envoy sidecars in a sidecar-based mesh, that exposes a full layer 7 capabilities of Envoy, including all of its vulnerabilities. And it represents a much wider, larger attack surface than if those sidecars were completely absent. Not to mention the fact that not all workloads are even proxied by a waypoint in ambient mesh as well. So we have a much more reduced attack surface when we're working in ambient mesh, and that's an improvement from a security standpoint. Next point, isolated credentials. The fact that we have the certificates that are needed to perform mutual TLS communication not sent to the actual workload pods, but rather given to ztunnel as a delegate to manage and maintain, also improves our security posture. That means that if an application is breached, for example, you have some kind of flaw that allows an attacker into an application, that they do not have access to the certificates, and those certificates do not leak, and we don't enable attacker impersonation. Another one is the fact that mutual TLS enforcement is improved. It's a better posture from the point of view, again, the absence of that sidecar. We treat the ztunnel as a hardened node infrastructure, just like other components in Kubernetes, like kubeproxy, and we ensure traffic is routed securely without relying on the proxies inside the pods. So it reduces the potential for all kinds of different attacks, unauthorized access, that could be caused by maybe a misconfiguration inside a sidecar. Operational simplicity also has, you may say, spillover effects on security, right? The fact that ztunnel updates align with node patching, that waypoints can be updated transparently without pod restarts, ensures that there's no situation where maybe something is accessible or some mesh policy is for some reason not in effect at a particular during a particular transitional period or what have you. Another one that's interesting to point out is simplified egress configuration. If you try to use sidecar-based Istio to configure egress, there's a lot of knobs, a lot of configuration parameters, a lot of API resources that you need to bring to bear, which is error-prone. And it could lead to maybe a misconfigured or insecure egress traffic. Whereas in Ambient, that's improved dramatically. I provide a link here to the ambientmesh.io website. Let me perhaps just visit it real quick for a moment. It's called Controlling Mesh Egress, which is a walkthrough on how that's done in Ambient, which essentially ensures that we have, again, full encryption of communication end-to-end, and the configuration is a lot simpler. Here's just a simple illustration showing some service D whose any request to a particular external endpoint can be modeled as a service entry and associated with a waypoint that ensures that all the traffic, external traffic, will go through an egress gateway, and the ztunnels ensure automatic mutual TLS traffic internally for that internal hop to the egress gateway, and from there doing TLS origination to the target service is very simple and does not require overly complex configuration. So it works that way by default. Another final point I'd like to bring up to show more or less the advantage, or one advantage from a security standpoint of running Ambient, is that Ambient has a lower resource footprint, which enhances resilience, especially to traffic spikes. So when you have high traffic, the security enforcement is maintained under load in Ambient. Whereas in sidecar-based mesh, where the envoy is running inside the pod, if you have maybe a denial of service attack or something of that nature, or increased traffic and that causes a situation where you have resource starvation, you may be in a situation where the proxies handling the very policies that are supposed to protect you are overwhelmed, and that leads to delays, dropped connections, or perhaps some kind of partial bypasses or temporary bypasses. And so that's another way in which Ambient Mesh is more secure and more resilient to these types of attacks. All right, so that gives you a few things to think about from a security standpoint, how Ambient Mesh sort of improves on the security posture of a system of microservices. Not only are the security benefits of sidecar mode retained, but what we see here is a more efficient and streamlined design that addresses security gaps that are inherent in sidecar mode and it does this through better isolation and a reduced attack surface. We talked about that, and operational simplicity, and we actually mentioned a couple of additional points besides. All right, thank you, and we'll see you in another video.